Okay, thank you all for joining the, either you joined us through the Ortelius Meetup group or the CDF online Meetup group. Thank you for coming on board and your interest in continuous delivery and how to secure your software supply chain. This is becoming more and more of a topic, so it seemed like a good and relevant topic for an online meetup to start really having a discussion about what kind of tools we should be adding into the CD pipeline. I am Tracy Reagan. I have been hosting these meetups now for a few years. Thank you to the CD Foundation for trusting me to pull these things off. This is being recorded and will be pushed out to the CDF community, as well as anybody who has joined these meetups. Today, I am happy to introduce Steve Taylor. He is the, full disclosure, he is our DeployHub CTO. He's also on the board of the Technology Oversight Committee for the CD Foundation and has done some work around some open source projects, including Ortelius. He is pretty much the senior contributor to that, and a project pushed by JFrog called Persia. He's also done some work around Stream 9 for the OpenSSF, which has to do with consuming SBOM data. So he has some experience and background in software security. On that, Steve, I am going to take myself off of the video and mute myself, and I'm going to hand it over to you.
Thank you. So let's get started here. Get to the right. There we go. So we'll just kind of level set some of the stuff that has been happening in the past couple of years. The amount of attacks that we've been getting through the supply chain have been growing tremendously. The hackers have figured out the supply chain is an easy way to get their malicious code into the process and distributed for them out to all the end users. So we've had this huge increase of 7 times higher than we've seen in the past. And as a result, the boards of the companies and like the CEOs, the C-level execs are considering cybersecurity a larger business risk. So they're putting more focus on security just because, you know, it can make such a huge impact when your company is taken out of, you know, blown out of the water for a week or so when you're trying to recover, even though disaster recovery plans are in place. Still a huge loss of revenue on that front. So they're really focusing on that level to make sure that cybersecurity is addressed. And then lastly, application teams and companies are really wanting to see more visibility into the application level security. There are things where, you know, we have at the edge, you know, our incoming routers and stuff like that are able to handle some like denial of service attacks and things like that. But that's just part of it. What you really need to be able to do is see what's happening at the application level to see where your vulnerabilities are. So when we talk about application security, we need to look at our DevOps pipeline. And our DevOps pipeline has basically 4 to 5 different areas that you can start addressing your security changes to. One is actually at the code, and we'll go into each one of these in detail. I'll just give a highlight here. So the first stage is like the coding and the pre-build side. So that's where the developers are actually doing their work. Then you have the build, which is creating your artifacts. and making sure that you are doing that level of automation at the build level. And then there's a post-build piece. Depending upon your build tool and your development language that you're using, you may need a post-build step for application security. And then you have your publish, which is where you actually are pushing out your artifacts to be consumed, some sort of registry or release process at that level. And then finally, we have our audit. When we go through and audit everything, how that takes what we're going to do with the data that we gather at that level. So we'll look at all these different stages here, and we'll dive into our phase one, coding and pre-build. So when we think about adding security steps to our coding and our pre-build, when I talk about pre-build, this is like when you do your git commit. You want to make sure that you have code signing enabled. So Git, you can enable two things. There's a signing piece, and then there's a signature piece. So the signing piece is where you actually use a key to sign your commit, and then you can associate your key to your GitHub repo or your GitLab repo, and then it'll give you like this verified tag for your commit. So that's one of the first things that you want to be able to do is generate your signing key, and then make sure that Git is configured to go ahead and do all of the signing for every change that you make. The next part is signatures. Signatures saying signed off by Steve Taylor, for example. And that's just another level to say that I've actually done this is what I really wanted to do, and I signed off on it. The next part we have is code scanning tools that happen at the code and pre-build level. The code scanning tools are going to be you have your SCA code scanning tools, so software composition analysis, Veracode, SonarQube. Those are type of tools that'll look at how your source code's put together and determine if there's any vulnerabilities at that level. Next, we have our repository scanning tools, CodeQL, Trivy, Dependabot, Frogbot. Those are actually looking at your repository, looking for secrets, looking for how your workflows are structured. Those basic type of dependency analysis. If you're looking at, like, if you have a Node.js program, it's going to look at your package.json to see if you're on the latest version of a package. Same thing with like Rust. Rust has this cargo TOML file that you need to look at dependencies for. So all the different languages are going to have some sort of files that are at the repository level that are going to be viewed and reviewed by these repository scanning tools. If you want a full list, go out to OWASP and check out what they have for those tools. Also, if you're a GitHub user, if you go to the security tab for a repository, you can turn on and off things like Trivy, CodeQL, Dependabot. Those are all configurable right from your repository there. So it's pretty easy to get up and going. So the next phase we're going to go into is our build phase. So this is where we're actually going to create our artifact. So we're actually going to start, doing compiles, packaging, things at that level. So one of the things that happen at the build phase that we need to address from a security standpoint is we want to make sure we're generating an SBOM. So some tools to really take a look at, especially if you're using Docker, AppCo. AppCo is like a replacement to apt-get. and some of the packaging management tools. Basically, AppCo is focused around building from source and getting you a clean artifact at that level. AppCo can also produce an SBOM. So your software bill of material is generated actually at build time. Same thing with the BuildX. When you run BuildX, you can tell it to generate an SBOM at the creation time. Other things we want to do at the build phase is we want to make sure we're signing. We want to sign our artifacts. So SigStore has a tool called cosign. Notary 2 has a tool. So those things we want to make sure that are being done. So we want to build build our code, generate the SBOM at build time, and then make sure that it's signed. Now, things like BuildX and SigStore, these tools will work hand in hand. So when you do the BuildX, it'll actually generate the SBOM and the signature at the same time. Other things we want to make sure that we're doing is at the build phase is we're not doing this on our own computer by just like doing a npm package, for example. We want to make sure that it's being done on a hosted build system. So you have Google Cloud Build, you have the GitHub, you have GitLab, Tecton, Jenkins. You want to make sure that it's being done on a build system, and that build system is actually locked down. So there's another phase that you can get into where you can make sure, like with Tecton, Tecton has something called Tecton chains, that will report everything that's happened during the workflow or the build process and give you like a log of exactly where things came from, so you know that you have a secure build system. Now, what will happen is if we're not able to do an SBOM at the build phase, we need to add in a secondary step into our pipeline. And this is where the artifacts are actually produced at the build phase, but the build tool wasn't able to produce the SBOM natively. So because of that, we have to go ahead and do a second step where we actually generate the SBOM based on the artifact from the previous one. So there's tools out there like Encore Sift. Microsoft has an SBOM tool. The OpenSSF has SPDX. Now these SBOMs are going to come in two formats, and they're for the most part pretty interchangeable. There's Cyclone DX and SPDX. Those are two different, I want to say they kind of are competing formats of your SBOM. But basically in the software bill of material, it's going to list all of your dependencies that your artifact is dependent upon. Now, one of the things I haven't seen yet in these SBOM tools is actually reporting the source code that was used at build time. What ends up happening is it'll report upon package dependencies, so dependencies that you have from a package to package level. But right now they haven't been generating at the very first level saying, you know, I just built this artifact, here's a list of all the source code, all the hashes for every single piece of source code that went in to create this artifact. So it's one of those, they haven't quite got there yet. The SBOM formats support it, but the tools just haven't been rolled out yet to do that. And the reason why that's important is when you look at your vulnerabilities, you want to make sure that you may have a vulnerability in this one file in your code base, and that's where the vulnerability exists. And we want to be able to track back to the actual commit that could have introduced that vulnerability. For example, like maybe there's a regular expression that enables a denial of service attack type of thing. And you want to be able to get back to that exact source code and that commit where that was introduced. So the SBOMs are evolving. At this level, we are when we're talking post-build, we're mainly going to get a package-to-package type of SBOM created. On our next phase, we're actually going to do our publishing. So we've created our artifact, whether it's a Docker image, a jar file, war file. You know, we're going to do our release now. So we're going to release our artifact out to a location that it can be consumed. So when we do a publish, if we're talking Docker images, we're going to push those out to OCI registries. So like Artifact Hub, Docker Hub, Quay are just a few of the OCI registries that are out there. You may also have internal OCI registries. You know, all the cloud vendors have them. So Google has theirs, the GCR, Azure has one. You know, basically AWS has their registry. So it doesn't really matter where it's going to end up. But what we want to make sure of is that when it gets there, we want to go ahead and scan again anything that was published out to the registries. And the reason why we do this this secondary scan is in case the build pipeline is not doing the vulnerability scan at the build or at the post-build step. So we want to make sure that we do that scan at that level. And also one of the things I've seen is different tools will find different vulnerabilities at different times. So some of the scanning tools work really well and will find a vulnerability like at build time. Like the CodeQL and Trivial will find things at build time or post build time, but after it gets out to Docker Hub, the vulnerability may show up 2 days later that we have a new vulnerability that we're not catching at the build time. So it's these things that we have to constantly keep running and keeping track of and keeping an eye on throughout the process. Because one of the things with securing your pipeline and your supply chain is you have to constantly do it. You just can't do it once and say, okay, I've done it. I've done my security scan at the code level. We're all good. But because we have vulnerabilities popping up every day, we need to be constantly looking over our code base and our artifacts that we've created. Now, one of the things that what will happen is the CVE side, the vulnerability side, they will get published to different repositories at different times depending upon the language. So we have things like NIST, MITRE, OpenSSF has the OSV dev, which is kind of like an aggregation, CVE details, GitHub advisories. So all these different locations we have to go and check to see if a new vulnerability has been found. And that's one of the things that we want to keep an eye on is making sure that that we're checking or cross-referencing those databases on a daily basis. So finally, we get to our pipeline audit, and one of the things that we want to do at this level is to actually audit what we did from our developer check-in all the way out through all the different stages. So when we did our code check-in, then we did our build, then we did our post-build, then we did our publish, and we did our release. We want to make sure we're auditing all of that. And one of the things in the supply chain process is we want to audit the supply chain itself to see if there's anywhere that things could have been introduced. When we went from our build phase to our publish, were there any new dependencies that were introduced that we weren't expecting? So did somebody hack the supply chain itself? This is where the audit process comes into play. And there's the Jenkins audit trail, Tecton chains are just a couple of examples of auditing the pipeline itself. So just kind of review when we go through and do our publishing. One of the things when we publish is we want to pull together all the information that we have. So we want to make it basically a giant cross-reference of the data that we've gathered from the developer check-in all the way out to the release. So some of the things that we want to try to pull out of each step in our pipeline is the SBOM. And then we want to take the SBOM and cross-reference that with the CVE. And then we want to make sure that when we do a release, we have that release being audited and any CVEs attached to that addressed. And then we want to keep track of what's happening at the changes, what changes were actually done from the developer all the way out. Now, one of the things we need to do is when we look at this from a microservices point of view, is we have all these repositories scattered about. So a typical microservice application is these days is around 200 microservices. So we have basically 200 workflows or supply chains that we need to monitor and then aggregate that information up into our logical application view. And then we want to be able to look at it from the logical application and see where things are falling over, which parts of our code base could have vulnerabilities that could be attacked. And then we need to make sure we address those. If we focus things on just at the low level, we'll be able to track it, but it's much harder to figure out what's running where, what's running in which microservice version is running in development versus which version of the same service is in QA and production. So we have to look at this from the high level perspective of pulling together and aggregating all the data up to a logical application viewpoint. So that's where the open source project that I work with, Ortelius, it'll hook in and grab for each one of those microservices the data that we want and do that aggregation up to the logical application view. Now that gives us information that we can really utilize. We can, be able to say for this application that's running in production, this is all the actionable data that we need to look at. So these are the new CVEs that popped up that we have to address within the last couple hours. And then we can then go through and say, oh, microservice A is the one that's giving us problem. Let's go focus on that. All the other 199 are good for today. So what this allows us to do is really give us that federated insight across all of our applications and all of the clusters. As part of that, you can answer questions like, where is Log4j running? Do we have which services are using these vulnerabilities? And being able to really pinpoint, in a few keystrokes, what is going on where and what needs to be addressed at that level. This really helps developers manage drift, see what's happening between the different environments, and address things quicker. It's amazing on how much time you can spend just chasing CVEs and fixes. Even though the fix may be just as simple as bumping to the this version to the latest one, knowing which ones have to be addressed and when really cuts down the amount of time on the development side. And then also it gives you the point of view of microservice A was the one that had the vulnerability. We just fixed that. Now we should just be able to test the test microservice A instead of having to retest all 200 services. So drastically cutting down on our time to production at that level. Again, we want to be able to look at the whole supply chain, aggregate that together. This is where we'll be able to bring in, the Tecton chains, the Jenkins audit trail, and give you that visibility of what's happening in your application level security. So all of this will happen on an automated level. So the way we introduce Ortelius into the pipeline is at the build stage and then at the publish stage or the release stage. It could go either place. But basically, when you generate your SBOM, we have a process, basically an Ortelius CLI, that allows us to capture that SBOM associated to the git commit of the source code, and then be able to track that as it moves through that version of your microservice or your artifact moves through the pipeline. So when it gets deployed and released out to production, that's where we make a second call out to Ortelius to say, I just deployed this service, this version out to this this cluster, for example, and now I know what's running where, the associated SBOM with it. All the supply chain information is aggregated to that version of that service, and then aggregated up to the logical application view. So what we're doing is we're gathering together all the moving pieces and persisting them, making a version of them to make sure that when we need to track something down, we have the information right at our fingertips. So now that we have our data, let's do something with it. So one of the things that we're going to be able to do is with Ortelius is centralize all of your DevOps and all your security and software composition into one place, give you that view of what your open source footprint looks like across the organization. If we have microservices involved, how is each microservice put together? And how is that microservice relating to other microservices and to the application view? And then we can look at the impact. You know, like I said, we have a package vulnerability. We can look at it from the microservice side, or the going from, I know that this service has a vulnerability. What are all the application teams using it? So if I fix this vulnerability, who do I have to tell to go fix and retest their logical application? Or from the other side, how does the security footprint look like from this application? Do we get the greens, the thumbs up, everything's coming up green, or do we have vulnerabilities that we need to address, and what is the level of risk that we're exposed to? Then also we can track at the logical application view what's happening in development versus production and all the stages in between. Is QA Does QA how's QA looking, or UAT? Because of that, we can version that logical application view across the different stages of the pipeline and give you that print, that look in between what's running in production, what's in QA, and see if things are getting fixed and how things are moving across the pipeline. And finally, when we talk about microservices, like I said, typical microservice applications getting around 100 to 200 microservices. How does that affect all the clusters that we have running? What we're seeing is, production is just not one single big cluster these days, but it's many clusters spread out across different regions of the world that we need to keep track of what's running in each cluster, compared to like a blue-green deployment, or a tiered deployment where we're going to go hit maybe the states at 3 o'clock in the morning, see how things happen, and then we're going to roll it out to the UK the next day, type of thing. So we'll be able to track what's happening in each level across that, and give you that view of how your security and supply chain looks at that point. So here's just an example of one of the a microservice environment. and looking at a version of a component is what we call them. So basically an artifact that we've created, all of the dependencies that are in it from the SBOM level, and then the corresponding vulnerabilities. So it makes it an easy dashboard to take a look at where you stand vulnerability wise. And then again, who's using Log4j? Basically, it's a search box. You say, I want to find out who's using this package, and we're able to give you the component that's consuming it, and then the application that's being affected by it. So that gives you that quick deep dive to answer that question, who's using what. So we have some exciting new architectural changes coming through for Ortelius. One of the things that we're actually going to be doing is utilizing a blockchain, so the XRPL ledger, to track historically the immutable data that we're gathering. So all the package dependencies, the application dependencies, the CVEs, the SBOMs, all that information is going to be pushed through an Arango database that we're going to use for caching. We're going to persist that information in the blockchain, basically the blockchain ledger. And then also we're going to persist the data over in NFT storage. The reason why we're doing this is the amount of data that gets generated from your supply chain process is huge. We were talking to one of the lead project managers over at Encore. They were just keeping track of the verified Docker images on DockerHub, and they ran their SBOM tool against those images for 2 weeks, and they ended up getting 3 gig worth of SBOM data. So we're going to be using this process to normalize data and do some efficient storage and be able to make it easy for folks to be able to find things and keep track of what's happening where in an immutable fashion. So if we look at the open source side of the security landscape, again, this is just the open source side. There's many other regular vendors out there, but if we're looking at the code and pre-build, there are open source tools from Veracode, SonarQube, the repository scanning, the CodeQL, Trivy, at the Dependabot. Those are already part of, just need to turn them on in GitHub. The build side, when you go ahead and do the artifact generation, AppCo and BuildX. Now, both of these, especially on the AppCo side, you need to do a little work because it actually changes up how you do your packaging. So that is going to be actually a change in your package manager to utilize that. BuildX will work with a basic Docker file, but there are some extra bells and whistles if you go ahead and change up the way you do your Docker images, you do build them, you can get some more benefits from both those tools. The hosted build systems, obviously all the cloud providers, GitHub, GitLab, Tekton. Some of them are going to have, like Tekton is going to have Tekton chains. That's going to give you the ability to audit the supply chain process. GitHub Actions, I haven't seen anything yet on that front. And I believe Google Cloud Build is starting to introduce some more like supply chain, immutable supply chain auditing around that. The signing side and attribution and provenance. The signing side, you have Sigstore, which is cosign. Notary 2 is coming out. There's other tools out there like iTododos is another part of attribution and provenance. So those are some of the tools that you want to look at from the signing and attribution side. Package verification, the Persia project, which is a build consensus process. So you actually build the open source projects on 5 different nodes and compared that they all came up with the same result, making sure that you didn't have a supply chain hack. Then post build, we're going to have the SBOM generation tools that are going to look at the artifacts. So SIFT, SPDX, Microsoft's SBOM. There's a couple other tools out there, depending upon your language that you're coding in. We'll have the different post build SBOM tools. And then when we publish, we want to make sure that we're publishing over to a registry that's being scanned as well. So like Docker Hub has their scanning, Artifact Hub for your Helm charts, Quay does scanning, Maven Central, the NPM world, PyPy, all of those registries have some sort of scanning happening at the publish level to see where you stand for the CVEs. And finally, the evidence catalog that pulls all of this information together is where Ortelius lies. So if you're interested in Ortelius, please join us. We're part of the CD Foundation. You can go to ortelius.io or you can go to the cd.foundation and you can find us there. Like I said, we have some exciting work going on. We have a new project that we're just starting up around the blockchain ledger, the IPFS and the NFT storage. And we're also pulling in additional OCI registries as part of the data storage that we're going to be utilizing as a side project or side option to the NFT storage. So we are looking for more contributors to dive in. If you go out to the CD Foundation, they have a calendar and you'll be able to find the Ortelius meetings out there. There's the general meeting. We just had one this morning, and then we have an architecture and outreach meeting that will be happening next week. So like I said, come out and join us. If you have any questions, let's go ahead and open it up. I believe there's the Q&A that we have enabled for this webinar. So if you have any questions, drop them on the Q&A. Or like I said, if you go out to the Discord channel here, you can go ahead and reach us on our Discord and ask questions out there as well.
And yeah, everybody is unmuted, so you can just ask a question or put it in the Q&A. I do have one question. When the OpenSSF Salsa or the Google Salsa project, in the phases, does it just primarily deal with the build phase?
That is the main area that Salsa is trying to address. So depending on which version of Salsa that you look at, there's one that I think has like 8 different areas that you can attack or are part of the attack plane. And I believe they simplified it down to 4 or 5 in the new version of Salsa. And what that is highlighting is places that you can introduce malicious code into as part of the build process. So like, for example, if I do a git clone and I check out the code and then I do my build, in between those 2 steps, if my supply chain if my workflow is not secure, I can introduce a vulnerability in there. So I could actually do like a curl command and go fetch some malicious code and put it into the build directory. So there's processes and things that they do at that level to ensure that there's nothing being introduced into the Salsa framework there.
But it's also just a recommended framework. It doesn't really specify the tools or how to get it done. Is that correct?
Correct. It just says we know this is how you can hack it. And here's some recommendations on how we're trying to fix it.
So the projects like Persia doing the package verification helps get you to those SALSA levels because you are addressing those gaps.
Correct.
Okay.
So like one of the things, so in the Persia project where it's a build consensus network, if you have five build nodes, they all check out the same code. And then one of the nodes is compromised where you go ahead and introduce some malicious code. What will end up happening is that one node out of the 5 will come up with a different result. And because it comes up with a different result than the other 4, that result from that build node is basically thrown away.
All right.
And the same thing happens like with the signing, those aspects of it. So when you build your code and you sign it, and then you do your release, and somebody downloads that release and they go to verify the signature and the signature's not matching up, that's where you know that that release has been compromised. So that's another one of the steps in to fix SALSA is to do signing as well.
I see. Well, thank you so much, Steve. You gave us a huge amount of information there. There's a lot to do in terms of building up that that DevOps process to add security, but it's well worth it. And with the tools I think you've given us, all of which are open source, you can do it at kind of a low cost, but there is a lot of human, the cost of the humans to put it together can be challenging. There is a project at the CD Foundation called CD Events that is sort of changing the way we put together our pipelines, allowing them to be more event-based so that you don't have to have all of these pipeline workflows to edit, to change, to make for every single one. And that may be another thing that folks should think about is moving to an event-based process. I believe that Jenkins and Spinnaker have looked at adding events so that some of the interoperability issues that we've had in the past won't bite us in the future as we start adding these security tools.
Yeah, it's amazing when you look at the amount of work. Like I said, if you have a microservices project that has 200 repositories, and you want to go turn on Dependabot for 200 repositories, it's more than a 5-minute effort.
Exactly.
You know, and turning on just Dependabot to make sure you're on the latest release of everything is, you know, really basic. I mean, it's a big win for a simple amount of effort, but when you look at 200 repositories, it grows, your amount of work grows exponentially. And then the next part is when you actually go find that you have a dependency that needs to be updated. Now you have 200 pull requests you have to go approve. You know, how do you automate that process? And then once you approve the pull request, how do you get tested all? You know,
yes.
so
and that's in a microservices environment in particular, that's where you're it's really starting to explode the complexity, and being able to pull together the information becomes more and more important.
Yeah, when we've been working with Ortelius and implementing you know, supply chain security, and we only have about a dozen microservices, that process is easy to implement, and we're able to keep track of it, and we can put some automation around it. But you know, the complexity, our new version of Ortelius is going to have about 30 different microservices. So it's growing quickly, and keeping track of all those different areas that you have to invest in is quite complicated. Because what I'm seeing is, in order to secure your supply chain, there's about 15 to 20 different, I won't say necessarily tools, but checks you have to do. You have to make sure you have GitHub, Git commit signing, and then you have to have your signature, and then you have to have your dependent bot, Privy. So the list is about 15 different things you have to do for every single repo to make sure you're getting a secure supply chain. So it's one of those, take a little bit at a time is what we found. Just do one thing at a time and figure out that process, and then keep adding to it. And that's where like CD events will come into play, which will be nice. Is I need to add in another scanning tool. I just go and update it in one place, and now the whole event process rolls it out for me.
Right. Instead of updating every single pipeline, every single workflow file. Yeah.
Exactly.
Okay, so next month we do have CDCon. CDCon is in Vancouver, May 8th and 9th, followed by OpenSSF Days, which is on the 10th. And it was all happening at the same time as Open Source Summit, which I believe is the 8th through the 11th. So if you're there, come find us. We'll be hanging out at the CDF booth. Ortelius will have a room. I don't remember the time and date, but Ortelius will have a room for a summit. I believe it's on the 8th at noon. So look for that in the schedule and in announcements coming from us. CD Events will also have a summit, and that will be on the schedule. So if that's something of interest to you, I would highly recommend, if you're there, go to the CD Events Project Summit. It's like an hour and a half where you can talk about what events will do and how far along the events framework is to getting a version 1 and getting it implemented. So we hope to see you all next month. There will not be a online meetup next month because CDCon is happening. So we'll see you all again in June. And thank you so much for being here. And Steve, thank you for that excellent review of security tools.
Thank you.
Bye-bye.